counting in the first one?
Here I have the D.
Oh, you're right. There's one more, isn't it? All right.
Should be 5.
No,
No, I mean
3.
3, yeah.
Must have fell off in the printing process. All right, we'll continue. Now, next, we're going to have a look at averages. And there's actually 4 types of averages. So, does anyone know the 4 different types? I heard mean, did I? Yeah, do you know the other ones? Median, mode, and which one? And one more I'll do today is mid. So I think you've studied this before, so you actually probably already know the formulas. So how do you get the mean average? You add up all the data and then divide by the number that you have. How do you get the median? It's the middle number, isn't it? But this is after you put the data in order. Yeah, ascending order. The middle number in the list. We'll do an example now. The mode, yeah, the most frequent one. And the mid, it's the minimum plus the maximum over 2. Okay, so let's do a calculation, practice each of them. So let's take this data here. I won't put it in order. I'll say 2, 1, 6, 3, 1, 6, 1, 2, 3, 7. Okay, so take out your calculators. Let's get the first one, the mean average. So that would be 2 plus 1 plus 6 plus 3 plus 1 plus 6 plus 7 over 7. You've seen this one before, yes?
Yeah, but I don't know what it got.
Okay, well now you know what it's called. What do you get here? 3. Let's do 3 significant figures. 3.71. Okay. Now, is that okay? I'm sure that's okay, isn't it? Median. I have to rank the numbers. So first is 1, and then 1. But what's next? 2, 3, 6, 6, 7.
Is it
Yes?
from low?
Yes. Yeah. And then you take the middle number. So if you have 1, 2, 3, 4, 5, 6, 7. Which number? Yeah, the fourth number here is in the middle. So the median is 3. Okay, let's see here. The mode. What's the mode here? No.
6 and 1.
It's not 1 and 6, and it's not 6 and 1. Any other answers?
3.
No, none.
There must be one that is more than the other.
Yeah. For you to have a mode average, there has to be clearly a number more frequent than any of the other numbers. And it's not acceptable to have a tie. So in situations where there is a tie, in this case between which numbers? 1 and 6. You can't say the mode is 1 or 6 or anything like that. It's just there is no mode. Okay? So if I was to add in one more number, now what's the mode? Now it's clearly 6. Just be careful with that one, okay, with the mode. It has to be a clear majority. Yeah?
If the median has even number, then how do we establish?
Yeah, good. If it was an even number, like if it was 1, 1, 2, 3. Yeah, you add the middle 2 and divide by 2.
Do we need to plus 1 at the end, like 1 plus 2 over 2 plus 1?
For which one? The median?
If the number is even.
Well, you just take the middle 2 numbers,
Middle 2?
add and divide by 2. Yeah. Is that okay? Yeah. And the last one is the midpoint. So what would that be in this case? 1 plus 7 over 2, which equals,
It's always over 2,
yeah, because it's like you're taking the middle of the two ends. It's kind of like the middle of the range, isn't it? Yeah. Now, it's important that you know it's not like one of these is the real average. The situation will determine which is the more appropriate average to use. So generally speaking, when you're looking at scientific data, for example, maybe you measure something 5 times and you take the average of the 5 results, which would be the more appropriate average to use? The mean average, right? Okay. But let's think about some situations where that's not the case. So, suppose you were looking at the average of people's salary. Why would it not be appropriate to use the mean average to represent the average of people's salary?
Because
The extremes. Yeah. Because if you have some data like this, suppose I have a group of a few people, and I don't know, let's say we have like a 30,000, 30, 35, etc., maybe up to 40,000. And then you have one person here who's on 3 million. If you take the average here, because of this number in the data, it would raise the average. And so you would say something rather silly sounding, like, oh, the average of this group of people is 100,000, even though most people are in the 30s and the 40s. So the median is most suitable for data where you have extreme values, like with salary. Okay. What about something like a mode average? When might that be suitable? Mode average. Yeah, this is where you have data and there's many values that seem to be the same, and this gives you confidence that perhaps that is more like the maybe true value. You know? So, I can't really think of an example right now. I'm trying to think of something where you record something, maybe you get 9 values the same, but then 2 of them are different. So you might feel a little strange taking the average when you kind of know 2 of them must be wrong. Maybe there was something wrong with the machine. So perhaps it'd be more appropriate to take the mode average. Do you understand? Depends on the context. And lastly, when might it be good to take a midpoint average? Can we think of an example? Yeah, midpoint average works really well when you have a large amount of data and you just very, very quickly want to get an estimate of an average. Because when you look at all of these methods, the mean will take some time to calculate. Why? Because you have to add up all the data, right? The median will take some time. Why? Well, because you have to order the data. The mode will take some time. Why? Because you have to count, right? But the midpoint can be done quite quickly because you quickly scan for the smallest and the largest value and divide them by 2. Do you understand? So midpoint is suitable when you want a quick estimation of an average and you have lots of data points. Do you understand? Yeah? Okay, so that's mean, median, and mode when you have data. Now we'll have a look at mean, median, and mode when you have tables. So can I scroll down? You're all familiar with that. Have you calculated any averages in any of your science subjects for any experiment?
Yeah.
Mean average for all of them? Yeah. Okay.
That's very interesting.
Right. Next now, suppose you have your data in a table like this. Let's say you have X here and F here. So let's say we have 1 to 3, 4 to 7, and 8 to 15, for example. They don't have to be equal. 6, 2, and 8 here. And I want the average here. So for these problems, what's the difficulty by having your data in this form?
We don't know the exact values.
We don't know the exact values, do we? No. So what could we do to fix that? Yeah, but we don't know what X is. I'm just telling you X is between 1 and 3. That's it. What you can do is you can estimate by using the middle values. So if you have some numbers between 1 and 3,
1 plus 3.
yeah, 1 plus 3 over 2 is 2. So you think, okay, I think these 6 numbers will all be roughly equal to 2. I would think these 2 numbers should roughly equal 5.5. And I think these 8 numbers will roughly equal, what's that now? 12.5 is it? No, sorry. 11.5? 25 plus 8 is 23. 11.5, isn't it? Okay? So, yeah. Just add, divide by 2. 8 plus 15 divided by 2 gives me the middle. Yeah? So what you're doing now is it's like you're saying, this is my data. I have the number 2, how many times? 6 times. And I have 5.5? Yeah, you get the idea? And I have 11.5, 8 times, etc. So, what would be the mean here? Well, you would have to do 2 plus 2 plus 2 plus 2, or a quick way to do it would be what? 6 times 2, which is 12, plus 5.5 times 2, which is 11, and 11.5 times 8, which is, what's that, 120? No, 120? Oh, no, 80, 92. Divided by what? Yeah, how many numbers will we have here?
16.
We'll have 16. So what's that, please?
7.
Okay? Right. Next now. Again, with this problem, how would I get the median?
From the root with the large.
First one, last one, 2.
No,
No,
median.
median.
Yeah? Hang on, yeah?
Add 6 to complete the from the unknown equals the middle of
That's it, that's it. Add 6, 2, and 8, and you get 16. If you have 16 numbers, where will the middle be? Well, 8 and 9. Because this is what you were asking me earlier, wasn't it? What do you do if you have an even number?
8 plus 9.
So I have to look at the 8th number and the 9th number. Now, in this list, what will be the 8th and the 9th number? Well, let's count. 6 of them are here. So this is 7, and this is the 8. So what did I say? We need the 8th and 9th, isn't it?
Yeah.
So that's 5.5 and 11.5.
We could take 7 shots.
Add them
8 and divide by
and divide by 2.
8.5?
8.5.
Why you didn't add the 5.5 and 5.5?
Oh, because you're looking at the 7th and 8th number. Isn't that the 7th number?
8 and 9.
Sorry, that's what I meant. The 8th and 9th number. Isn't that the 8th number? Oh, this is the 8th here. Sorry. 8th and 9th then. Yeah.
Yeah.
Now, in this case, we do have an answer. What is the mode here? 11.5. Yeah? And then lastly, what is the midpoint here?
2 plus 11.
Yeah, well, it's not 100% clear. Like, do we use 2 and 11.5, or maybe we should use 1 and 15? Although it shouldn't really matter too much, because after all, we are estimating. So, suppose we were to use 2 and 11.5, what would we get?
6.75.
And suppose we were to use 1 and 15, what would we get? 8. Yeah? So obviously they're different. Now the reason for the difference is both of these are an estimate, because do we know the original data? No. What are we doing? It's like we're reconstructing the data, isn't it? So it's not right to say one of these is right and one of these is wrong. What is right to say is both of these are different estimates of the middle number. But we can't truly know the middle number unless we have the original data. Yeah? Now, if you were to ask me which do I think is a better estimate, well, no, actually, I'll ask you. Which do you think would be a better estimate? To use the 2 and 11.5 or the, what did I say, the 1 and the 15? Yeah. Oh, I heard someone say 2 and 11.5, which is fine. But I wonder what people would think if they picked 1 and 15. Why?
Is the range of the value.
Yeah, like the first box has a range of 1 to 3, doesn't it? So it seems quite likely that some of the numbers should be near 1 rather than near 2, right? Like if I have a box of values between 1 and 3, then that kind of suggests that I might have some 1s, doesn't it? I kind of feel like using the 1 and the 15, the 8 would be more accurate.
So now, how did you get the mid?
1 plus 15 over 2.
Why?
1 is the smallest,
Yeah.
15 is the biggest,
Yeah.
divide by 2.
Okay.
Yeah? Yeah? Like, suppose I was to say teachers' salaries are between €1 and €1 million. That's an inappropriately wide box. Okay? So if I was to make the box smaller, then it would give you confidence that you probably have values at both ends of the box. Right? Make sense? Now, the last thing to look at is there is a small problem with using your table like this, because you might say, well, what do I do if I have a value like 7.9? Which box do I put this in? Oh, okay, good. We're thinking. Which box? The second or the third box? Well, I'm glad none of you are saying the first, so. It's definitely not the first box. Yeah. So what we usually do is when we have tables like this, it wouldn't be too unusual to convert it into a more accurate table, which I want to show you how to do that now. So what I'll do, keep it the same number, 3 here. And what I'll do is I'll make it more clear where to start, comma, where to end. And do you remember these brackets?
Yeah.
Yeah. So the square one means
It's the last, you cannot.
you can include it, and the round one, not included. So what you ask yourself is, okay, what is the smallest number that could round off to 1? 0.5. So this is what we would say, if you want to be really clear about it, is what the smallest value in this box could be. So imagine that you were doing some experiment and you collected some data and then you rounded the data off. So you got a result of 0.7. To the nearest whole number, what would that be? 1. And so that would go into the first box. Now, think very carefully. What number would I put here that would mark the end of what the rounding process could be for the first box?
3.4.
Yeah, 3.5, but not including 3.5. So for example, yeah, 3.4999 would round up or down to 3 or to 4. 3.4999.
Up to 5.
Up to 4.
No.
No, down. Down.
3.4.
Because it needs to be 3.5 to run.
Yeah, exactly.
Wait, what?
Yeah. Guys, you know how to round numbers. You did this in primary school. 3.4999. Does that round up to the whole number, the nearest whole number as 4, or does it round down to 3? Okay, fine. So 3.5 is the boundary here.
Yeah.
Oh yeah.
And then 3.5 begins here. And what would be the upper number here? Sorry. 7.5. And then here? 7.5. And then the last number? 15.5. So now it's crystal clear what goes in each box. So for example, if I said to you 3.1. 3.1, which box? First box. Okay. 14. Last box. 8.2. Last box. There's no confusion now, right? It's completely clear what box has what numbers. Yeah? So just to give you a little bit of vocabulary, these numbers here, the 0.5 and the 3.5, they're called the class, yeah, the upper and lower boundary, the class boundaries. Okay? So, obviously, I've been calling these boxes. That's not the technical name for them. We can call these class intervals or intervals with boundaries. Not boxes with starts and ends. Okay, but it's the same meaning. Yeah. What do you think will be the meaning of the term class width? It's like the range, yeah. So what would be the class width of the first one here?
0.5 minus.
It would be 3 units. What would be the class width of the next one? 4.
8.
And 8, is it? For the last one. That's the class width. And lastly, these here, I gave you the name already. You call these the midpoint estimates. Okay? Now, the reason I'm giving you this vocabulary is because in the exam I've seen questions like this before. They would give you this table and they would say something like, what is the lower class boundary for the middle box? So what is the lower class boundary for the middle box? 3.5.
3.5 and
Yeah.
7.5 and 7.
No. The question was, what is the lower
Oh,
class boundary?
okay.
Which table did you see earlier? This one?
They give you the one on the left. This one here.
No, that's what I meant.
This one here. This one here. And they would say, so the question, if it said, what is the upper class boundary for the middle box? 7.5. What is the class width for the first box?
0.5 or 0.4?
0.5.
Should be
3.
No, Hazel, we had a good discussion a few minutes ago about this. What is... Oh, guys, why is there questions? What's the question? Okay, good. Okay, let's try this again. Listen carefully. The table on the left. The lower class boundary for the middle entry is... Good. And the upper class boundary for the middle entry?
7.5.
Good. And the class width for the middle entry? 4. Good. Okay. You know these words now? Yeah? What?
Why is the class width is different in each box?
Oh, there's no rule that says they have to be the same. This is not a rule. It's just a normal practice. But the boxes I had you made earlier, we deliberately made sure that they would have the same width. Okay? But there's no rule that says this has to be the case. It's just unusual if it's not, but not unacceptable. What you counting? Got it? We're good? Yeah. All right. Yeah. Okay. So, there's only one little situation here that might be a tad confusing. Suppose I have something just like 0 to 5 and then 6 to 10. Just keep it short like this. Right, for the second box here, this guy, what is the upper boundary?
10.5.
And the lower?
5.5.
And here, what's the upper?
5.5.
And the lower?
Minus 0.5.
Negative 0.5.
There you go. Yeah, minus 0.5. Yeah. Yeah. There's only one situation. Yeah, good man has it. There's only one situation in which maybe you would want to choose the 0 and not the minus 0.5. What might that be? Yeah, if you know that the data has to be positive, then it would be inappropriate to say the lower boundary is minus 0.5. So, for example, if these represent like counting something, you know, it would be appropriate to have only positives. Yeah? How did you get this and not the why we use the 0.5 and not the 0.4? No, seriously. Like, how did you know this and not the last thing? Okay. Mystery, I guess. Right. So, just for the last 5 minutes, for exam purposes, questions 4, 5, 9 and 13. Yeah. 104, roughly. Right, try these now, please. No, listen, 4, 5, 9, 13.